A very good afternoon to all of you. I hope you are still enjoying your day and still full of energy to be able to attend today's lecture. So we have covered electrostatics by far. So today we are going to discuss about Gauss's law. Actually, this law tells us that what will be another approach to be able to find electric field due to symmetrically charged distribution bodies. Okay, so let's start with today's lecture. And today, as we have found electric field with the help of different configuration in the previous lectures of electrostatics, today we will be able to find electric field with the help of Gauss law, which we are going to cover by now. Okay, so let's start with today's lecture. Before that, as I say in almost every class, if you have to download PDF of today's class, whatever we are writing, that will be available in a PDF on eCareerPoint app. So in that app you can go to free section tab where you will be able to find the PDF of this YouTube class. No problem. Download eCareerPoint app from Google Play. Whenever you download this app, you will encounter many courseworks and courses available there about which you will be curious, like shall I join them or not. So I will suggest to watch all the freely available lectures in that particular course. If it is suitable for you, if it is useful for you, if you feel that there is proper tuning between the faculty who is teaching and what you are understanding, then that's a really good option for you to join. And in case you buy a coursework there, do apply this code, because it is going to give you 10% off on the price, which is already reasonable for you. Okay, so do explore, and I will suggest, if you like it, do join. Keshavan, hi, how are you? I am good. Okay, so let's start with today's lecture, Gauss theorem. So what it is about? So it tells us the total electric flux linked with a closed surface when a charge is placed inside. Total electric flux linked with a closed surface when a charge is placed inside, like this. For the closed surface, when a charge is placed inside, for example, suppose this is a surface we are having. Okay, I have taken random shape of the conductor, randomly shaped conductor I have taken. Inside the conductor, plus Q1, minus Q2, plus Q4, these three charges are present. And just outside the conductor, minus Q3 and plus Q5 charges are present. Okay. So according to Gauss law, electric flux associated with these charges which are present inside, plus Q1, plus Q4, minus Q2, minus Q3, plus Q5, electric flux due to all of them combinedly will be given by Q inside by epsilon naught. What is Q inside here? Q inside here is the total charge present inside the closed surface. Okay, the total charge present inside the closed surface is Q inside for us. And according to Gauss's law, what happens? We write this expression, phi flux is equals to E dot ds. Flux is equals to E dot ds enclosed. What is the meaning of this symbol? This symbol means integration for a closed surface. Integration for a closed surface. Hence, Gauss law is applicable only for closed surfaces. Gauss law is applicable only for closed surfaces. Other than that, what are the things we have to keep in mind? See, for this flux, that is electric field dot ds, we can write this is going to be equals to Q inside by epsilon naught, such that we are able to write Q inside as the summation of charges which are present inside. Just like this. electric flux phi is equals to integral of E dot ds is equals to q inside by epsilon naught plus q1 minus q2 plus q4 by epsilon naught. Now focus here. This electric field expression, this electric field E vector is due to all the charges present in the region, that is the charges present inside, that is these three charges plus q1 minus q2 plus q4, as well as the charges which are present outside, that is minus q3 and plus q5. So whenever we are applying Gauss law equation, E dot ds integral is equals to q inside by epsilon naught, then no doubt we are taking q inside in our formula. But this electric field which we have mentioned in the integral, it is going to be due to all the charges present in the region, whether they are present inside the closed region or they are present outside the region. Is that clear? So this electric field intensity is due to all possible charges present in the region, both inner as well as outside. One more thing we have to consider is this law is suitable for symmetrical charge distribution only. Okay, why we are saying it is suitable for symmetrical charge distribution? Being suitable is a different thing and being able to apply the law is a different thing. We can write this equation integral E dot ds is equals to q inside by epsilon naught for any closed surface, but this law will be useful for us in order to find electric field due to any configuration only and only when the charge is symmetrical. If the charge is not symmetrical, there is no chance or possibility of being able to find electric field using this Gauss law. Okay, that's the reason it is suitable only for symmetrical charge distribution. Now let's do example about it. So before actually proceeding to questions, sir, ds is what? Okay, so this formula must be crystal clear in our mind, that if we are having this region like this, if we are having any random region like this, any random shape, and I am taking a small element here, if electric field is flowing from this region, this is a small element I have taken, let's say area vector of this small element is ds, area vector of this small element is ds, so we can say that integral electric field dot ds, E dot area vector ds shall be given as flux for the surface. Electric flux passing through the surface will be given by integral of E dot ds, where electric field is passing through this ds area vector or ds area element. So what is ds? Keshwan, area element. No problem. So let's move on to questions. So this is our first example. So what we have done in this, we have taken a cube and inside the cube at the body center we have placed a charge plus q. No problem. Just imagine that this is plus q charge which we have placed, and from this plus q charge these electric field lines are coming out everywhere, in every direction possible. Electric field lines are coming out across 720 degree. I am not saying 360 degree, not in a plane, I am saying 720 degree solid angle, means in all possible directions, in all the 3D plane, electric field will be coming out of this point charge. Now we are expected to apply Gauss law for this charge placed at the body center of this body. What is this? Cube. Now if a positive charge plus q is placed at the body center, find electric flux through shaded face. Where is the shaded face? I will shade it now. Okay, where is the highlighter? Let me highlight the face. So this is our shaded face. I want you to find electric flux due to this plus q charge through this shaded face. Okay, so if we have to do this one, the most basic situation we have to apply. We can apply phi net flux coming out of this cube. Net flux coming out of this cube is equals to q inside by epsilon naught. Q inside by epsilon naught. Now tell me, there will be electric field lines coming out of all the sides. How many sides are there for this cube? How many sides are there? This surface is there, the opposite surface is there. So 4 surfaces are there on the side, and 1 surface at the top and 1 surface at the bottom. That means total surfaces are 4 plus 2, that is 6 surfaces are there. So we can say flux due to this plus q charge. Flux means flow of electric field lines through all the areas, surface areas. So flux due to this plus q charge across all the 6 sides, 4 and plus 2, 1 at the top and 1 at the bottom, will be actually equals to q inside by epsilon naught, and we already know the value of q inside. How much it is? Plus q. So plus q divided by epsilon naught. Now in this case what we can do? This flux is total. If this is total flux, can we write 6 into flux across each surface? 6 into flux across each surface is equals to q inside by epsilon naught, that is plus q by epsilon naught. Can we write that? No problem. So in that sense we can say flux across each surface shall be equals to q divided by 6 epsilon naught. And since across each surface the flux is going to be same, we can say flux across the shaded face is equals to q by 6 epsilon naught. This is going to be our answer. So let's move on to next situation. Let's move on to next question. Now in this again we are taking the same cube. This time the difference is we are placing this plus q charge at the corner of the cube. Now what is my purpose? My purpose is to be able to apply Gauss law on this configuration. Now in order to apply Gauss law, what is more important for me? What is important for us? It is important that this plus q charge is present symmetrically with respect to whatever volume or box we are considering, right? So I want this plus q charge to be present at a symmetrical position. So in that case what we can apply? Suppose we are having this cube. On this cube we are having plus q charge here. I wish to hide this plus q charge symmetrically from all sides. I wish to hide this plus q charge symmetrically from all sides. So in that case what we can do? So basically, if we have to hide this plus q charge only on the planar surface, we can say that if we keep 1, 2, 3 more cubes at the bottom only, then 4 cubes will become, and they will be able to hide this plus q charge from the bottom side. If we have to completely hide this plus q charge in a symmetric manner, how many boxes, how many cubes we will require? 4 cubes at the top, 4 cubes, so that it is coming in the middle of those 4 cubes, right? So 4 cubes at the top and 4 cubes at bottom together, if are present for this plus q charge, we will be able to apply Gauss's law for this configuration. So what I am telling, to hide plus q symmetrically, eight boxes, 4 at the top and other 4 at bottom shall be required, okay, including the given cube. So we can say that 4 boxes at the top, 4 boxes at the bottom, total flux across those 8 cubes, will be equals to phi total is equals to how much? Q inside by epsilon naught according to Gauss law, and that's why I am writing plus q by epsilon naught. So in this case, what we can do, this phi total can be actually written 8 times into phi each cube, 8 times into phi each cube is equals to q by epsilon naught. That means we can write phi across each cube is equals to q divided by 8 epsilon naught. No problem. We have taken 8 boxes. For 8 boxes we have applied phi total is equals to q inside by epsilon naught, q inside is plus q by epsilon naught, and this phi total can be written 8 times into flux across each cube is equals to q by epsilon naught. No problem. Phi each cube is equals to q upon 8 epsilon naught. Now I know that what will be electric flux passing through one cube. What will be electric flux passing through one single cube due to this plus q charge placed at the corner of this surface. So what we can do from here, now tell me, for this plus q charge, this top surface, this side surfaces, both side surfaces, is there any flux or electric field lines from plus q which are going to cross these surfaces? Like if I have to shoot an arrow from plus q, shall I be able to shoot an arrow like this? It will go inside like this. Not possible, right? So what I will have to do, I can understand clearly that if any electric field line is going from plus q charge, it will always be parallel to these surfaces, like one surface, second surface and the top surface. These two side by side surfaces and the top surface, across those there will be no electric field lines due to plus q crossing them. Is that clear? If the electric field lines are not crossing the surface, we cannot count that as flux, okay, because they are passing from the surface being parallel to the surface. They are not crossing the surface and entering inside. So we cannot count those electric field lines from plus q which are parallel to this surface and this surface. So out of 6 surfaces, we have 6 surfaces in one cube. Out of 6 surfaces, 3 surfaces are gone, okay, because this one and the topmost one cannot be counted in total flux. There is no flux passing through these 3 surfaces due to plus q. So where will be the flux actually passing? You might ask, sir, where will be the flux actually passing? You are refusing for these three surfaces. How we are supposed to think about the other surfaces? Okay, so for that I will tell you, leave these three, top and the sideways. From bottom, flux will pass. Electric field lines due to plus Q will pass from the bottom surface and this surface as well, and the sideways surface. One is this one and one the near one. Okay, that one, 1, 2 and this bottom surface 3. I hope all of you understood that we have to consider only these three surfaces. Which are the three surfaces? This one, 1, 2 and 3. Okay, no problem, not the upper one. Be aware, don't get confused. Okay, not the upper one. I am asking about this surface. Okay, third one, first, second, third. So now out of 6 surfaces we have only 3 surfaces. So that means 3 into 5 each surface. 3 into 5 each surface is equals to Q upon 8 epsilon naught. So this will give us 5 across each surface. Each remaining surface is equals to Q upon 8 into 3, that is 24 epsilon naught. Okay, no problem. 5 across each surface will be equals to Q upon 24 epsilon naught. Veravan, no problem, clear? Keshavan, Veravan, Jayant. Okay, so this is how we are supposed to find flux passing through any of the shaded surfaces like this. Suppose if this was my shaded surface, then flux passing through this one and the other two, this one, shall be same. So that's what we have calculated. So let's move on to next possibility. Again we have taken a cube. Again we have considered a cube. What we can do here? Now see, if a positive charge plus Q is placed at the edge center of a cube, find electric flux through shaded face. So let the shaded face be this one. Okay, so flux passing through this surface is phi1, and obviously due to this surface also it will be phi1 because they are symmetric for plus Q. So for this surface and this surface I have given. For this surface I actually wish to know how much will be the flux due to this plus Q charge. Okay, no problem. Now focus here. How many cubes are required to symmetrically hide this plus Q positive charge placed on the edge? See, according to me, one is already there. On one box we have placed a charge at the edge. So we require 1, 2 and 3. 3 boxes more to be able to hide this plus Q symmetrically. So you can say one box you can keep here like this. One more box we can place here, one more box we can place here. So basically 4 boxes at the bottom, and exactly in the middle of them plus Q charge is placed. Okay, 4 boxes, 4 cubes at the bottom, and exactly in the middle of that plus q charge is placed. So in that sense you can actually try to consider this. So you can say plus q can be symmetrically hidden between 4 cubes. Plus q can be symmetrically hidden between 4 cubes. Hello Vinayak, I am good. How are you? I hope your prep is going good. So today's lecture is actually meant to be basic. In case you find it very basic and conceptual, it is meant to be like that because this is first lecture. So first lecture of Gauss law is all about the basics. From second lecture there will be more number of problems where you will find yourself like juggling your mind. But for now, today this lecture is meant to be completely conceptual and basic. That's the reason we are doing basic things. Okay, but if these things are clear, things will be way easier for you later on. So now plus q can be symmetrically hidden between 4 cubes. If plus q can be symmetrically hidden between 4 cubes, what we can do? Phi total is equals to q inside by epsilon naught. That is our formula, or that is our equation of Gauss law. So this is plus q by epsilon naught. Now in this phi total, what is included? See, again, as I have explained in the previous example, this plus q charge present on the edge will not be responsible for any flux passing through this surface at which this plus q charge is present and the adjoining surface where this plus q charge is present. So this plus q charge is actually sharing the surface of two faces. Okay, plus q is sharing surface of two faces through which no flux due to plus q shall pass. Plus q sharing surface of two faces. Okay, this surface, this face and this face, through which no flux due to plus q shall pass. Okay, so that means how many surfaces are remaining for us? Out of 6 surfaces, 2 faces will not have any flux due to plus q. So out of 6 surfaces, 4 surfaces are still remaining. So for those 4 surfaces, top surface plus bottom plus shaded and adjoining. Adjoining surface, this surface. So these 4 surfaces are remaining. We can easily write from this q total, we can easily write 4, not 4 exactly, because all are not symmetric. This time all are not symmetric. This is phi 1, this is phi 1, but this is phi. Then the adjoining surface will also be having flux phi, and I am supposed to find electric flux passing through one of the shaded surfaces. Is that clear? No problem. So for that, what I am doing, 2 phi, that is flux passing through this shaded surface and the immediate adjoining surface, plus 2 phi 1, that is flux passing from the top and bottom surface, phi 1 plus phi 1 is equals to q by epsilon naught. So from here what we can do, we can easily guess that phi will be equals to q upon 2 epsilon naught minus phi 1. This will be my answer for the given question. Q upon 2 epsilon naught minus phi 1 will be the flux through the shaded surface. Clear? Let's move on to next question. Now, this is uniformly charged infinite sheet. If this is uniformly charged infinite sheet and this is sphere, shell, not solid sphere, shell. Now find electric flux coming out from the surface of sphere. Can we apply Gauss law directly? Because for every closed surface we can definitely apply Gauss law. E dot ds integral is equals to q inside by epsilon naught. We are not supposed to find electric field, but we can directly say phi net is equals to q inside by epsilon naught. Do you agree or not? No problem. So if we are supposed to write q inside, that is the charge present inside this sphere, I am already given that on this sheet charge density is sigma coulomb per meter square. First of all, tell me, are all of you able to imagine the photo given to you? What is happening? Are all of you able to imagine the photo given to you? Okay. You imagine that this is a gola of ice cream. Okay. This is a gola of ice cream, a sphere of ice cream. Now you must have seen knives which are very wide, which are having a width, good width, right? So across that ice cream gola, I am putting that knife. Across that ice cream gola, in between I am putting that knife. Okay. So what will happen? Surface of the knife will be stuck in between, because from both sides ice cream is sticky. Okay. And surface of the knife will get stuck in between the ice cream sphere. So what will happen? That surface is having charge. That's what I am telling you. The surface of the knife which is stuck in between is having charge on it, for which we can say charge is sigma coulomb per meter square. Are you able to imagine? Imagination must be clear. That's why I tried through that, something like related to food. So phi net is equals to q inside by epsilon naught. So what we can say from here? Phi net is equals to q inside will be equals to how much? Sigma into area. How much area will be there? I don't know the radius of this circular surface which is coming inside. So let's find out this radius, small r. This is capital R radius, capital R, and this is x. So we can easily say capital R square minus x square is equals to small r square. Or you can say small r is equals to under root of capital R square minus small x square. So now if you ask me what will be the area which is stuck inside the sphere, if you ask me what will be the area stuck inside the sphere, so in that case I can actually convey that area will be sigma into pi into r square. Sigma into pi r square, or you can say surface area of the circular part which is stuck inside. No problem. So from here we can say sigma by epsilon naught into pi into what is r square? Capital R square minus x square. So from here phi net is equals to sigma pi r square minus x square by epsilon naught. So this is going to be our net flux coming out of this spherical shell due to this sheet which is stuck inside. Is that clear? Did you understand what we are doing? How we are applying the equation of Gauss law in order to find electric flux coming out of a surface, closed surface? No problem. Let's move on to next example. Now, I am placing a charge here at the origin, okay, like placed, come. So this is plus q. This is plus q kept at the origin. From the origin, see, is this x, y and z axis visible to you? So basically you can say that in the 3D plane we have placed this charge at the origin. Veravan, you are getting everything crystal clear, right? Comment fast. Now this plus q charge placed at the origin, due to this I wish you to find what will be electric flux passing through this surface. What will be electric flux passing through this surface? This shaded surface. Actually this question we have already done. How? That you have to remind yourself. Like very recently we have done this question. Still this question appears different, right? Actually we just have to imagine, we are just supposed to imagine that this surface is a part of a cube. If we imagine this as a surface, as a part of a cube of side A, because from here the distance is coming A, the sides of this surface is also A everywhere, and this distance will also be A because it will be equals to the distance here. Wherever this plane is placed on the x-axis, the same distance will be there on the z-axis because of this. So you can say, if I imagine this shaded surface as a part of a complete cube, I will be able to write the answer directly because I already know the answer. How? Focus here. For a charge placed at the corner, what is the answer we have found out? We have found out answer will be q upon 24 epsilon naught. Q upon 24 epsilon naught is the flux passing through the shaded surface or flux passing through each surface when a charge is placed at the corner of the cube. Similarly, here also the charge is placed at the corner of the cube if we imagine this surface to be a part of a complete cube. Okay, so the answer here will be direct. Phi shaded is equals to q upon 24 epsilon naught. Is that clear? No problem. Veravan understood? How with the help of the previous question we can directly write the answer to this? Okay. Now this question we can solve. In this question what is given to us? A uniformly charged thin rod with linear charge density, okay, given already, lambda coulomb per meter, is made to pass through a cube of side length A such that we get maximum flux through cube. Okay, no problem. See, it is made to pass through a cube of side length A such that we get maximum flux through cube. This must be clear in our mind that for maximum flux through cube, Q inside should be maximum. Q inside should be maximum, and that is possible only when the biggest length of this rod is present inside. Q inside will be maximum only and only when the biggest length of this rod will be present inside. And what is the biggest side which can be there inside cube? Say all the sides of a cube are equals to A. If I think about this diagonal, face diagonal, this will become A square plus A square under root. So this is also going to come root 2A. But if I consider a diagonal which joins this opposite vertices here, from here to here, okay, such that this side is how much? Root 2a, and this height is a, then we can easily tell that the length of this diagonal is going to be equals to how much? Root 2a whole square plus a whole square under root 3a, 2a square plus a square. Root 3a will be the length of the diagonal present inside. If this is the length of the diagonal, the value of phi net is equals to going to be how much? Q inside by epsilon naught. So the same formula we have written by Gauss's law, equation of Gauss's law we are using, and instead of Q inside by epsilon naught, instead of this Q inside in this formula, I am putting charge present inside this, the maximum value of charge present inside this cube, because I am taking the maximum length which can be possible inside. So for that we can write lambda, that is charge per meter, coulomb per meter, into the length of the diagonal, that is root 3a, that is the maximum charge which can come inside due to this rod, divided by epsilon naught. So this will be our answer for the net flux passing through closed surface. Is that clear? No problem? Okay. So that's all for today's class. We will continue doing more and more problems, advanced problems, better problems than this in the subsequent classes. Just keep your basics clear, everything crystal clear in your mind. Don't assume anything by yourself. All the best. Take care. Enjoy your day. Don't forget to attend the next lecture, because that is going to be literally crucial, very crucial. Why? Because today was basics, and that will be the place where we are going to climb. Okay? Take care.